Here we go. Let's get ready for a math warm-up today. I would like you to take these 4 fractions and write 3 equivalent fractions for each one. So go ahead and pause your video and do that for me now, please. All right, let's see how you did. I took each one of these fractions and I multiplied 1/3 first of all by 2. Got 2/6, then I multiplied by 3, got 3/9, multiplied by 4, got 4/12. And I did that for each one of these. So 3/4, I got 6/8, 9/12, and 12/16. 1/7, I did 2/14, 3/21, 4/28, and 3/8, I did 6/16. 9/24, and 12/32. Now you might have multiplied each of those fractions by a different number and gotten a different answer, and that would be perfectly fine. You could have picked 10, you could have picked 100, you could have picked whichever number that you chose. Next, I'd like you to take a look at our math message today. The first part is to list the first 6 multiples of 8. So go ahead and pause your video and list those on a sheet of paper. All right, let's have a look to see how you did. You should have gotten 8, 16, 24, 32, 40, and 48. Next, what I'd like you to do is list all of the factors of 36. So remember, these are factors. Go ahead and pause your video and do that now for me, please. All right, let's check to see how you did. You might notice that I did a T-chart off to the right here. I put 36 at the top. I started with 1 times 36, 2 times 18, 3 times 12, 4 times 9, and of course 6 times 6. Then I came over here and I listed them in number order, putting my commas in between. So you should have 1, 2, 3, 4, 6, 9, 12, 18, and 36 as your factors of 36. So now let's take a look at this question that I have here at the bottom of the screen. What can we say about multiples? So what do we know about multiples in general? So when we think about multiples, multiples make numbers bigger. Okay, if you take a look up here, our numbers are getting bigger, right? When we think about factors, what do we know about factors? Factors are always less than what you are finding the factors for. So for example, if we look here, we were finding factors of 36. All of these factors are 36 or less. Okay, they are 36 or less. If I asked you to find factors of 9, for example, all of my factors would be 9 or less. If I asked you to find factors for 8, it would be 8 or less. All of my digits would be 8 or less, or that number or less than that number. So multiples make numbers bigger, and factors are always usually less than the number that you're finding the factors for. All right, let's get started today. We are doing a lesson to find more strategies for finding common denominators. Why, you might ask, are we doing this lesson? Well, first of all, we have to have common denominators to be able to add or subtract fractions. We also need fractions that are easier to work with numbers. So we're going to look at fractions and we're going to make some decisions about whether we're going to use a certain strategy or not based on the size of the fraction. So some fractions will be easier to work with than others, and that will make sense once we get more into the lesson. So how are we going to do it? Well, we're going to use 3 strategies with us today. The first one that we've done before, but we're going to revisit, is make a list of equivalent fractions looking for one with a common denominator. So that's why our warm-up today had to do with finding equivalent fractions, just to kind of get you in the habit of doing that, remembering the process for finding those. Number 2, see if one denominator is a multiple of the other. And 3, multiply the 2 starting denominators. So now we're going to discuss each one of these by itself. So let's get started. All right, let's take a look at Rule 1. This is the rule where we're going to make a list of equivalent fractions looking for one with a common denominator. So what I'm going to do is I'm going to take the fraction 2/3 and I'm going to take the fraction 1/5. And I'm going to make equivalent fractions until we get to a denominator that they have in common. So again, I'm going to use the multiplication rule to do that. So when we did that, we multiply numerator and denominator by the same number. And usually we start with 2 and we work our way up. So 2/3 times 2 is going to give me 4/6. And then we would have 3 times 2/3, which would be 3 times 2 is 6, 3 times 3 is 9, and then 4 times 2/3 is going to give me 8/12, and then 5 times 2/3 is going to give me 10/15. And I'm going to see how I'm doing. So I'm going to take 1/5 and I'm going to multiply that times 2, which is going to give me 2/10, times 3 is going to give me 3/15. Now, if you'll notice, I have a 15 here as a denominator, and I have a 15 here as a denominator. So that means I can use 15 as my denominator to do this problem. So what we'll do is we'll take this 10/15, which we know is equivalent to 2/3, and the 3/15 is equivalent to 1/5. And now we're going to make a new equation. And then we're going to add our numerators, 10 plus 3, which gives us 13. And remember, we do not add the denominator. So there you have it. This is strategy number 1, finding equivalent fractions and looking for a denominator that they have in common. So now we're going to take a look at strategy number 2. See if one denominator is a multiple of the other. So see, all of those days that we practiced listing multiples is going to come in handy. So we're going to look here. My denominator in my first fraction is a 3, and I have a denominator of a 9. So is 3 a multiple of 9, or is 9 a multiple of 3? Why, yes. 9 is a multiple of 3, right? We would list our multiples of 3 as 3, 6, 9. And so guess what? That would be our starting point for figuring out our common denominator. So the 5/9 won't change, but our 2/3 we're going to change to have a denominator of 9. So how do I go from 3 to 9? I multiply times 3, which means whatever we do to the bottom, we have to do to the top. So 2/3 is going to be equal to 6/9. So we're going to do 6/9 plus 5/9. And remember, we do not add our denominator, so that will stay the same. 6 plus 5 is 11. And this fraction just so happens to be larger than the whole number 1. So we could also say that this is equal to 1 2/9. So there you have it. This is strategy 2, looking at our denominators to see if one of them happens to be a multiple of the other. All right, our third strategy today is multiply the two starting denominators. So that means if we have this equation, 1/3 plus 3/8, if we multiply the two starting denominators, that means we're going to multiply the denominators by each other. So that means I'm going to multiply 1/3 times 8, and the 3/8 is going to get multiplied times 3. So where did I get those numbers from? This 8 and the 3. Well, actually here. Okay, so we're going to go ahead and multiply. So for this first one, we would get 8/24. And for the second one, we would get 9/24. So now we have the same denominator in both of those. We're going to add them. 8 plus 9 is 17. And our denominator is 24. So there you have it. This is our third strategy. Taking those two denominators, the 3 and the 8, for example, in this instance, and we multiply the opposite fraction with that number to get our common denominator. Okay, so let's summarize what we've done in this lesson today. We have learned 3 strategies to find common denominators. And we know that finding common denominators allows us to add and subtract fractions. What you're going to have to do in class, however, is decide which of those strategies works the best for the problem that you are trying to solve. So that's going to be the tricky part. So don't worry, you've got this, and we will practice more in class. Until next time.